The last test in the test of the mean difference is a one-way analysis of variance. We call it as a one-way ANOVA. What is a one-way ANOVA? We recall back in the independent sample t-test, we can only compare between two groups. However, if we are interested in finding the difference of a numerical data among more than two groups, we are dealing with different combinations of pair of means. If we use multiple independent t-tests to compare different pair of means, we are at risk of increasing type 1 error. There is a perfect way to handle numerical data on comparing more than two groups. The analysis is called analysis of variance, or we call it as ANOVA. It is called one way because we are looking at the impact of only one independent variable on the dependent variable. By mathematics, analyzing the variability variance of group can tell us whether the between group difference is large enough to reject the null hypothesis. We compare it statistically to the within group differences based on F-test. What is the F-test? Alright, the F-test. F is defined as variation among sample means divided by variation among individuals in the same sample. In theory, the larger the overall F value, the more statistically significant it will be, or in other words, there is mean difference between groups. There are two types of data required in the one-way ANOVA. The first one is a one dependent variable, right? Your variable must be numerical or continuous only. For example, the age of student, the blood pressure, cholesterol level. Another type is a one independent variables. In the one independent variables, your data must be categorical with more than two levels. For example, the drug groups. You have the drug A, drug B, and also control. Teaching style, whole class, small class, and self-paced. We move to the example of suitable research design in ANOVA. So in the ANOVA, usually suitable for the two types of research design, such as experimental or randomized trial design or observational design. In experimental design, the subjects are assigned randomly to the different groups of interest and the difference of the effect are measured. For example, let's say a pharmacist dispenses drug for lung function to patient with asthma. Then he or she wishes to determine whether there are differences in the mean peak expiratory flow rate, PEFR, among three different drug groups. Let's say we have the drug 1, drug 2, and also control. So here we can see the figure here. By using the randomization, alright, we separate the three group of drug 1, and drug 1 to look at the effects of the drug on PEFR. Another example is an observational study design. This is the second type in the research design. In an observational design, the subject define their own groups after being recruited as a sampling unit. The exit sample is the comparison of average level of satisfaction among the three different groups in the population. So the figure that we can get from the observational design is starting from the population. So we have the three groups here, and then between the three groups we can comparing the level of satisfaction. Before we performing the analysis of variant ANOVA test, we need to look at the assumptions for ANOVA. There are 5 assumptions for one-way ANOVA test. The first one is to test variable must be numerical or continuous, right? The second one, the data are taken using probabilistic sampling technique, right? Must be random. The third one, the groups are independent of each another. Each group must comply the normality assumption. And the last one, homogeneity of variance, which means that the variance for each group should be equal. So you need to remember that the assumptions of number 2 and 3 should be settled at research design and sampling techniques stages. Let we use the penguin dataset to analyze the one-way ANOVA test, right? So in the one-way ANOVA test, we have the 5 steps, right? 5 steps. The first one is the hypothesis statement. The second one, we checking the assumption. The third one, we can perform one-way ANOVA. Number 4 is the interpretation, and the last one, we present our result. Alright, so we come out the research question and also the hypothesis in the first step. There are 3 research questions and also they have a hypothesis testing, the null hypothesis and also alternative hypothesis. We move to the second step is the checking assumption. As I mentioned previously, the assumptions of random sampling and independent data are determined by the study design and sampling design. So the first one, we check the normality assumption where we need to separating the species into different sets, right? So we separate the species. And then we checking normality, right, by using the Lilly's dot test. And then the result for the chromograph, the Lilly-Force normality test is here, right? So we get the result for the chromograph's normality test for the checking normality. After we get the output, right, the normality checking, we need to interpret the result. So based on the normality analysis using Lilly-Force test, we can conclude that there are normality distributed for bill length for Adelie penguin, right? The same technique before this. So we need to explain the D statistic and also the p-value for each output that we get here, right? For each output, either 3 types of the species. After we checking the normality test, alright, so the next one we checking the homogeneity of variance where we check the leaving test, alright. So here is the syntax or the coding for the homogeneity of variance, and then we get the result for the leaving test. And next, the last one, we interpret the result based on the leaving test. We can see here, alright, so the p-value is 0.06019. The degree of freedom is a 2339, and the f value is a 2.8336. So means that we can conclude there is a variance for all groups are equal since the p-value is more than 0.05 here. After all the assumption is made, we can performing so one-way ANOVA. So how to perform our analysis of variance, right? ANOVA. So here is the function or here is the syntax by using the AOV function, right? So this is the syntax how to conduct the one-way ANOVA. Is a fit AOV, alright. This one is the analysis of variance ANOVA, alright. So here is the result. After we conducting the analysis of variance by using the function AOV function, we need to interpret each result that appear in your result.